All right, so example 4 says, given the equation, given there, describe the transformations that occur from the parent graph of y equals sine of x and sketch the graph. So tell me about the transformations. Start on the left. What's the very first transformation that's happening in that equation? It's a negative. It's a negative.
Oh, it's going to flip.
It's a reflection. Y'all are jumping ahead. Reflection across what axis?
X.
Good. Now what is the 2 going to do?
The 2 is going to make it stretch.
Good. It's a vertical stretch by 2. Now, we're not going to talk about the transformation part with the x because we use those things for other stuff. So, what is the period of this graph then? Remember, your period is 2 pi over b. So, we know our period is going to be 2 pi over, what is b?
3.
All right, and then tell me about that phase shift. Or the horizontal shift, right? So, what is your phase shift?
You have to plus 6 and then
Plus 6 pi over
divide by
3, which is 2 pi. So we're going to go to the right 2 pi because it's positive. Yeah, that's going to make fun for when we actually go to graph it, isn't it? That's okay. We're going to work our way through it. All right, so first thing is a sine. So make sure we're looking at our sine table. And what are we going to do to our x values?
add 6 and then divide by 3.
Add 6 pi and divide by 3. And what about our y's?
Multiply by -2.
Good. So I'll do the y's, y'all do the x's. All right, so I'm going to take all the x's, all the y's and multiply by -2. Well, you should have volunteered for it. And now let's take our x's and let's add 6 pi and then divide by 3. So I'm going to take the first one, so 0 plus 6 pi divided by 3. 6 pi over 3, which is 2 pi. Exactly what we said we were supposed to get, right? And we got pi over 2 plus 6 pi divided by 3.
Can we not just add 2 pi?
No.
Can we not just add 2 pi over 3?
No, because the x has to be over 3 as well. So we got pi over 2 plus 6 pi. And then divide that by 3. And we should get, I think it's 13 pi over 6.
Yes.
All right, I'm going to take pi plus 6 pi and divide by 3. So 7 pi over 3. That's a little high. I'm going to bring that down so it matches up with a 0. And then if you want, you can find how it's changing each time and continue your pattern. Excuse me. So find your largest exponent, which is 6. So put them all over 6. And so 12 pi over 6, 13 pi over 6, 14 pi over 6. What's next? And I'm going to have to reduce that. So that's... And then 16 pi over 6 reduced is...
8 pi over 3.
Good.
Oh my gosh, it's the prime numbers.
Is that 15 over 6? You should know these by now.
Yes, 15 pi over 6.
5, 7, 13,
And yeah, because you divide them both by 3.
17,
15 divided by 3 is 5. 6 divided by 3 is 2.
19, 23. I had to memorize them at one point.
What were the really big ones you memorized?
Ladies.
We're going for the prime.
All right, so now we go to graph these. The only problem is my table starts at 2 pi, right? And 2 pi is not even on my graph, is it? But I can make it be on my graph because I'm not far from it. I see 3 pi over 2. It's got some space after. It's got to be close by. And so several ways I can do it. For one thing is... there's 6 spaces in between 0 and pi, which means each line is a pi over 6. There's also 6 lines between 0 and pi, which means there's going to be 6 lines between pi and 2 pi. So I'm going to use that to continue. So here's 1, 2, 3, 4, 5, 6. So right here is 2 pi. Okay, and I know I've got the point 2 pi 0 right there. Now, the nice thing about the sinusoidal functions are, remember, that it repeats itself, right? So, if I was going to repeat, remember, the 2 pi 0 and the 8 pi over 3 0 would be in the same location. So, as I go to the left, it's like going up my table. So, if I go to the left 1 unit, then I'm going to be up at 2. And then if I go to left another unit, I'll be down at 0. But hold on, though, because we got to make sure, are we going to go every line? Are we going every 2 lines? What was our difference? Yeah, it was a pi over 6, because remember we had 12 pi over 6, 13 pi over 6, 14 pi over 6. We were changing by pi over 6. And we just happened to said earlier that every line was a pi over 6. So it is going to be every line gets a dot. All right, so as I work my way backwards from the 0, 1 line back is going to be up at 2. 1 line back is going to be at 0. Another line back is down at -2. And then I'm back at 2. I'm sorry, 0. I said 2, but I meant 0. And so there is a full period. And then I can just continue my pattern to draw the rest of my graph. Did I skip something? Ah! I did. I skipped the very first line back. I knew it was looking weird. That's why I'm like, something's wrong. Thank you. There we go. Now my spacing looks better. Which I was going to talk to y'all about that anyways. So,
Oh, dang it. Wow, I suck at this one.
and so something I didn't point out on the other one, but you should always look at your graphs when you're done, guys, okay? Do your little hilltops, do your valleys, do they look approximately the same width, okay? That's when I looked at that one and I'm like, there's something wrong. That one just looked wider than the other, but I couldn't see it, and that's when I'd ask, did I skip something? And then y'all said yes, I'd skip that first line because I just couldn't quite see it, but I knew my graph looked wider there than it did anywhere else. So, and sometimes it happens, like right now, to me, my graph looks more narrow there, but when I check, I did what I was supposed to. It's probably just I drew it a little, I didn't go out as much around the curve up there at the top or something. So I just kind of look at my tops and my bottoms and make sure they look approximately the same width, because I've seen it where y'all do skip a line on accident. So just make sure you kind of look at it with your eyes and make sure. All right, so there's a graph for that one.